Hello everybody, welcome back to Felsefe in the YouTube channel. It's me, Burak, and we have a valuable guest once again here with us. It is Ege. Hi Ege, how are you?
Hello Burak, how are you?
I'm also fine, thanks a lot for asking. So today, after the postponing of mock exams by 1 week in Turkey, we are going to solve some IBDP Physics HL paper 2 questions. And this is Specimen paper from 2014, right? Yeah, 2014. And again, what do you think about the Specimen paper? We were talking about it being a very good paper, right?
Yes, it's a bit challenging, and I think it's going to teach us a lot of things today.
Definitely, because we have a variety of topics, so this could be also a good paper for mock exams as well. So who knows what will happen, right?
I mean, we solved previous papers for the syllabus.
Yeah.
And those papers are much easier than this Specimen paper.
Definitely. And this is very exclusive, to be honest with you.
Yes, and next level past paper.
Right. So shall we start?
Yeah, let's start.
Okay, so I'm not really sure if you will have many viewers right now, because right now we don't have any. But just in case if we have any viewers, I would like to inform that should we have any questions, please just ask us. Maybe we can do small chapter reviews as well while solving the questions. So again, would you be in favor of starting with the first question?
Yes, of course.
Okay.
So let's start the question. So let's read the question first. Okay. Let's try to understand it. In the drop tower show, containers with experiments inside of them are fired upwards inside a vertical tower, and the container moves under the influence of gravity and eventually falls back to the bottom of the tower. And most of the air is removed from the tower so that air resistance is negligible. While in flight, the container and its contents are in free fall. Okay, so we know that it's in free fall. Okay, and it's asking the container is fired vertically upwards with initial speed 48, and determine the time that the container is in flight. Okay, I think it's a pretty easy question, a kinematics question. Let's write our answers. So I think we should use the data booklet here, and in the data booklet, this equation is given. Let's write the equation. So we know that our initial speed is 48, and let's write it, and minus, because it is being thrown with 48 meter per second, and our acceleration will be downwards. So it is 4.981 times t. And in order for this to be 0, t will be 9.8 seconds. So wait a second.
Actually, this is t up, right?
Yes, it is it is for the up. It is 4.9, and it is going to reach upwards 4.9. And for this to come downwards, we are going to need one more, 4.89. So we have to multiply this with 2. There we find 9.8 seconds.
Yep. So let me go with the next question. So in the next question, we will need a data booklet once again, because it says at the end of the flight, the container will fall onto a tank expanded with styrofoam, and the container has a mass of 480 kilograms. So it will slow down, but it will move for 8 meters in that styrofoam expansion. So let's find the average force that acts on the container due to the spheres. So if we are asking if we are asked about the average force, definitely we are going to use Newton's second law of motion, F is equal to m times a, and we know that, let me go with this one, we have to calculate firstly the acceleration that it will go through while doing that. So let me just use the data booklet, and we will say v square will be equal to u square plus or minus, so we will use the minus 2as, and we know that this has to be equal to 0. And our initial speed was 48, so 48 squared minus 2a, and it will move for 8 meters in the styrofoam, so this is 8. And when we solve for it, we will find that our acceleration will be equal to 144 meters per second square. Therefore, we can say that, first things first, mass of our container is 480 kilograms times the acceleration from here 144 will give us a result like 6.9 times 10 to the power 4, and plus we have to calculate also its own weight, because container has a weight, so it has its own acceleration as well, and it will be once again mass times acceleration. Mass is 480 kilograms, and acceleration is in fact gravitational acceleration, which is 9.81. Therefore, we will have this sum of those two forces, which will give us a result like 7.4 times 10 to the power 4 newtons, right? So this is the average force. So the thing we did is that we calculated the acceleration by using the data booklet, then added the force due to the acceleration of the container on its own, and the sum gave us an average force. Next question, right?
Yes.
Okay.
Could you let me know it?
Let me give you. Okay.
So it's saying outline why the experiments inside the container. This is really important to understand. Let's read the question carefully. It's asking inside the container could be considered to be in dateless conditions. So let's think of a container, okay? And it's falling downwards. And let's put an object on it. This is container. And this is a quick review. This is the object. So when it is going up downwards, it's 9.81 meters per second squared. This is also going down, and it will feel no gravity actually, because they are both going down. They fall at the same rate, and so we can write that. And also there is no reaction force either, because they are falling at the same rate. So we can write the reaction force is 0. Because they fall at the same rate. And this is a very good question, I think.
Yeah.
Let's ask the next question.
So, the next question, it says the tower is 120 meters high with an internal diameter of 3.5 meters, and the air has been removed, and it had a pressure of 0.96 pascals. So it says now imagine that the temperature is 300 kelvins in the tower. So what would be the number of molecules? So we will directly remember that already from the data booklet. PV is equal to nRT, right? PV is equal to nRT. Then, by using this information, we can write the values that we are already given. And we will just solve for n, which is moles. So please do not forget that we have to take a last step, right, again? Because if we are given a mole, we have this statement, number of molecules, not moles. So let's solve for n, and it will be PV over RT. And we know that P is 0.96 pascals times volume. So volume of a cylinder will be equal to PR square times H, meaning that the area of the base times the height. Therefore, we will say P, and our R will be 1.75 square times H. And now you may say, where did you see that 1.75? As if the diameter is 3.5 meters, then the radius will be 1.75 meters. That's why I wrote this. Over R is a constant given in the data booklet, 8.31 times 300 kelvins. Please write them in kelvins because sometimes question may not give in kelvins. Right, again, do you remember those kind of questions given in Celsius convert to kelvins?
Don't fall for the IB tricks.
Definitely. And making this calculation, we will find the result, and the result in here has to be multiplied by Avogadro's constants. I will write it like this. Both sides have to be multiplied by Avogadro's constant, because this part will give us moles. So moles times Avogadro's constant will give us how many molecules are there inside this. You may remember this, and by making this calculation we will directly find that this result will be equal to 2.7, I guess, right? Yes, 2.7 times 10 to the power 23 molecules. Okay, fine. So yes, we can go with the next question. Again, I will let you annotate.
Okay, let's clear this. Okay, so it's asking outline whether the behavior of the remaining air in the tower approximates to that of the ideal gas. So guys, let's quickly review the ideal gas. Okay, Murat, please please correct me if I make any mistake.
Yeah.
Ideal gas. So in ideal gases, we know that the molecules have negligible collisions between each other. This is very important, and it is really important to know this to answer the question. Negligible collisions, and also they have very negligible molecules. Negligible molecules. Okay, so it's. I mean, when you think of this, we have 0.96 Pascal, and also very low temperature. I mean, it is not very low temperature, but it is considered. It is very considerably low. It's not high. And what was the temperature? It was 300 Kelvin, I guess.
Yes, definitely.
So in order for a gas to be ideal, to be an ideal gas, you need to have low pressure and high temperature, moderate temperature. And why is this? Because if molecules move at very high have very high kinetic energy because of temperature, they will have very high speed. So there will be negligible collisions between them. They will hit the sides of the container more. And we need low pressure as well. So we will write yes, because low pressure and we can write high temperature.
Yeah, temperature is moderately high compared to the room temperature.
This is really important to know this. I mean, low pressure, high temperature. This is also asked in MEB questions, YKS.
Yeah. Right.
And this is really important to know this.
By the way, we will just stop our stream for 2 minutes because we have to change our Zoom link. So we are now back in business, and actually always in business. So again, here we have another question, right? It says this is the velocity versus time graph for this, how can I say, action. And it is said, state the quantity that is represented by the area ABC. So, since this is the deceleration part, we can say distance traveled while, since this is a velocity versus time graph, the area under how can I say, velocity versus time graph gives us its distance traveled while stopping in styrofoam. Okay. Can we proceed with the next question?
Yes.
I guess it's... Oh, by the way, we lost all of our viewers. No.
Yeah.
Okay, they are coming back.
Where have you gone, guys?
Okay, they are coming back. No problem.
All right. Burak, we missed the question.
Yeah, sorry. Okay. Do you want me to draw this?
It doesn't matter, I mean.
Okay. So it says it is introduced, air is introduced to the tower. Remember that it was vacuum previously. So now the air is at atmospheric pressure, and use this axis to draw the diagram of velocity versus time graph for this instance. So we can say that it will not reach that much of a velocity because it will reach a terminal velocity while going through this, right? So due to terminal velocity, we will have a decreasing gradient by time, and normally our since the distance has to remain same, the area under our graph has to be less. The area under our graph has to be the same. So we will say that it will have a decreasing gradient, yet have a longer line. So something like this. Okay, so the maximum point will be at a lower point, but our graph will go longer because we want the distance and the area under our graph to remain the same, since this indicates the distance and it has to remain as 120 meters. Yet we will have the same part for here. So by eye you can see that the distance under the graph, velocity versus time graph, are the same for both cases to make the distance traveled to remain exactly the same. However, since we have the concept of terminal velocity due to air friction, air resistance, it is going to have a decreasing slope with time. Therefore, we will have a longer graph. Anything I'm missing again? No, right?
No, I think it's very good. And we can mention, did you mention terminal velocity? I was fixing my headphones.
Yeah. So about the terminal velocity, as you may know, after a while, due to the air resistance, the upward force due to the reaction force of the air resistance, meaning the air friction, will be equal to the gravitational acceleration, gravitational force. Therefore, at this point, the velocity will become constant. And as you can see over here, it is having a decreasing slope, meaning that decreasing acceleration. And at this point, about here, we reach the terminal velocity, almost the terminal velocity. Because after a while, we will have no acceleration since both forces will be equalized. Therefore, we can see that our graph will end up at a longer point. It will be longer compared to this because the area over here, the yellow area, has to be equal to the blue area by I. Since this is the distance traveled by the container, so since it cannot change, we will have a longer graph. Okay? So next question. Again, we have Kirchhoff. Do you want me to solve this?
Yes.
Okay. So the first thing that we are doing is we are going to use first law of Kirchhoff, and it says check the joints. Okay, this is a joint and this is also a joint. Now I will assign, as you may remember from our previous classes, we will assign some directions. I will say clockwise for both of them. This is clockwise and this is also clockwise, I'm going to say. And now, those are assigned randomly, by the way. Now, let's say, I will say this one will be I1, the first current. So since now we are changing over here, I will say this is I2. And let's say over here we have I3, let's say. We know that the currents entering to the joint and the currents leaving the joint have to be equal. So the first thing that we are going to write, let's look at X. At point X, I realize that I1, which is entering to the junction, should be equal to the emerging currents. They should be equal. Therefore, I will say I1 is equal to I2O plus I3 because they are emerging and I1 is entering. And you may write the same thing for, how can I say, Y as well. But as far as I remember, we will not need this. And now I will do the second thing. Let's start to go with the loop 1. And this is loop 2. So for the first loop, let's start from point Y, okay? Now I am at point Y. I am proceeding, and I have 9 volts. And we are going from short negative pole to the long pole. Meaning that, just remember from our previous examples, it is like the elevator. We are going from down the elevator, up the elevator. From negative pole of the battery to the positive pole. So, in these kind of situations, we are going to write plus 9 volts. I am proceeding, and I am following the direction of the loop, meaning that I am going down the currents, meaning that I have to use a negative sign. So since I am going down the currents, I have now 3 ohms resistor, and I1 is going through this. So as I am going down the how can I say, stairs, I will write this will be negative 3I1. I hope we understood why we said negative, because I am following the direction of my currents, direction of my loop. And if I see that if the direction of my loop is as same as my currents, it is a minus, it's a negative. Because if we have an elevator, this elevator is a battery. It is taking the charges, giving them enough energy, and then they are going down the currents. Perfect. So now I'm at point X. Now I will go back to my point Y. I am following the direction of loop 1, and I realize that loop 1 has the same direction as this I2 over here, meaning minus once again. So minus 6I2. So proceeding, I am at point Y once again, joint Y once again. Therefore, as I started from point Y and came back to Y, this should be equal to 0. Is there any point that we didn't understand over here? If there's a point like this, please just tell me, I can just re-explain it. No problem. So, secondly, let's do exactly the same thing for the loop 2. This was for loop 1. So let's write for loop 2. Now, let's start from X this time. I am following the direction of loop 2. I started from point X, I am here, and I realize that on 2 ohms resistor, loop 2 and I3 are on the same direction, meaning that I am going down the current once again. So I will write minus 2I3. Let's proceed. I am now going to 12 volts battery, but I realize that this is the positive side and this is the negative side. So this time I am going down the current once again, because now normally, you know, at the positive pole we have higher currents. Yes, exactly, Özge. Yeah.
I think
definitely.
It's SG, right?
It's perhaps. Yeah.
It's SG. Yes.
Yeah, SG, yeah. So yes, because we came back to the same point, so there cannot be any potential difference between those points. Since we started from point Y, we came back to Y. The same case will happen for point X.
And also, Burak, I would like to add a little thing.
Yeah, of course.
There's also a charge conservation, current conservation. So you need to equate it to 0 to
Exactly.
like,
yeah. And about this 12-volt battery, 12 volt cell, it goes from positive. Positive is the current travels from conventional current travels from positive pole to negative pole. But this time we see that we are jumping from positive to negative. So this has to be minus 12 volts. Minus 12 volts. If the direction of our current takes us from negative to positive pole, this is a plus because we are going up the current. But if we are going from positive pole to negative pole, we are going down the current, so negative. So let's follow loop 2. Loop 2 is going in this direction. Oops, I am at point Y, and I came here to 6 ohm resistor. Now I see that direction of loop 2 goes in this direction. However, I2 goes opposite. I2 goes opposite, meaning that I2 does not follow the loop's direction. It doesn't go down the current, it goes up the current. Therefore, I will say this is a positive. This will be plus 6I2, and now I am back at point X. I'm now back at point X over here. Therefore, we have those 3 equations and we have 3 unknowns. So one thing that we can do over here is that we will try to eliminate them. So why not to take this equation and substitute into loop 1 equation. Loop 1 equation. Now I will just write loop 1 once again over here. It will be 9 volts minus 3, I will just substitute it, I2 plus I3 minus 6I2, and it will be equal to 0, right? Now, it is, maybe we can write it in one more step, 9 volts is equal to, it will be negative 9I2 and negative 3I3 is equal to 0, right? So now let's use those 2 equations over here. I hope we understood it. We wrote our Kirchhoff's first law by substituting into the loop 1 equation. This is for loop 1 still. This is for loop 1. And I will just use it with loop 2. So to make this how can I say, simultaneous equation, I can say that the I3 can be eliminated over here by multiplying this one with negative 2 and this one with 3. This one with 3. So we will find that I3s will cancel each other since one will be 60 and the other one will be minus 6. So over here I see minus 36 volts plus 18 I2, and then I'm going with the second equation over here. It will be minus 18 volts plus 18 I2 will be equal to 0. Since both sides were already to 0, then we will say for this equation we have minus 54 volts plus 36 I2 is equal to 0. Therefore, can we not say 36 I2 is equal to 54 volts? To find I2, it will be 54 volts over 36. And this will be exactly 1.5. And 1.5 amperes. And what was the question saying? Using Kirchhoff's laws, show that 6 ohm resistor has 1.5 amperes going through it. We found down below I2 is equal to 1.5 amperes, and I2 goes over 6 ohm resistor, and it has a value of 1.5 amperes. Hence we showed it successfully. So you may say, now what would happen if we had negative results? I will discuss it in the next question. Do we have any problems regarding this question? I will just show the entire parts like this. If there is any question about Kirchhoff's, I can just explain it. Was it clear? By the way, again, I was really afraid that I wouldn't find the results. Kirchhoff is always this case.
And you sometimes find like negative results, but don't freak out. I mean,
don't freak out.
I mean, you will explain in a few seconds.
This is always physics. This is always physics. It may be about directions as well, so it's not like mathematics. Any problems? I guess we don't have any problems. Just a quick summary. We used Kirchhoff's first law by using one junction. You may use also two junctions, in which we have it over here. So then we assigned some random loop directions, and using this loop direction we indicated if the resistors and batteries we are going down the current or up the current. Thank you very much, Altay. If they are going down the current or up the current. So we said if it is a battery, if our loop takes us from point negative pole to positive pole, this is plus. If we are going from positive pole to negative pole within the battery, this means this is negative. And for the resistors, if our resistor has a current that is in the same direction as our loop's assigned direction, this is negative, and vice versa. So we had two equations over here. One was loop 2's equation, this one, and the other one was we substituted our very first yellow equation into loop 1 and we derived this one. So with a simultaneous equation you can just eliminate one of the unknowns, and then we finally found that I2 will be equal to 1.5 amperes, which was exactly the value that was asked to us in the question. Perfect. Shall I proceed again?
Yeah, let's. I can solve the next question.
Okay, definitely. You can see the screen, right?
Yes.
Okay.
Okay. Calculate the potential difference between X and Y. So, if in our equation we know that voltage is equal to current times resistance, and Burak just found that current is 1.5 ampere and resistance is 6, as you can see in the diagram, where we found 9 volts.
Yep.
And let's see the other question. Okay? Outline whether X or Y is at higher potential. So, Burak, let me draw this. Sorry, let me erase. Let me draw the 6 ohm part. And your current direction was this, right? Was downwards.
Exactly.
Okay, so we said that it is X and this is Y. So in the battery, let's think of a battery, it goes from high potential to low potential, right? I mean, the current is directed downward, so it goes from high potential to low potential. It is always the case in battery, and this is the main principle of batteries. So we will say that X is at higher because current flows from X. That's it.
Yep. It goes down the currents. So X has to be higher. If we had found I2 to be negative, the current cannot be negative since it is Q over T. I mean, both are like scalar vectors, scalar quantities. Therefore, we would just reverse the direction. We would say I2 goes from Y to X if we had found a negative result, but we didn't. Okay.
And if we did, guys, don't freak out, just reverse it. Just reverse the direction.
Because we randomly assigned it at the beginning.
Yeah. And we may not have. And this is quite possible. I mean, you may not know the direction of the current. Physics is not always predictable. And if you find negative, just reverse it and you will find a higher potential.
So, next question. Oh, yes, capacitance.
Oh,
great.
Yes.
This is great.
11th graders, you don't need to hear this.
But you may just listen it to just have an idea about it.
Yes.
So, it says we have such a circuit, and this is a charging and discharging circuit, by the way, for capacitors, and it has a resistor 3.3 kilo ohms, and there's an electronic switch, and our capacitor has a capacitance of 4.7 microfarads, right? So it says at time 0, switch is moved to position 1, and draw a graph of how potential difference V across the capacitor varies with time t as it charges. A time scale is not required, so we can say that we have 6 volts over here, so our maximum value will be 6 points. But now what I would like to do is, this will become an asymptote, guys, because complete charge is not possible in electricity. So I will say there will be a curve, but a decreasing curve, just like, this. It will be an asymptote like this, right? Again, you can draw better curves than me, maybe. Okay, next question.
Okay, this is an easy one.
Yeah,
and,
right. Will you go for it, or do you want me to go for it?
Yeah, I can find it.
Okay, great. Let me just clear it for you.
Okay. So it is saying a single pulse of charge is produced by moving the switch S to position 2 for 6.3 milliseconds. Bro, can you show the diagram again?
Oh yeah, sure.
Let's see if it charges or discharges, and let's make sure of that. Okay, so we can see that in position 1 it is being charged, and in position 2 it is being discharged. And we are going to make use of that. Okay, can you let me annotate?
Yep.
Okay, so it is saying 6.3 milliseconds. Let's convert it into seconds. And when we take a look at, let's first find the right equation. Times, this is the Euler's number, minus t over tau. This is the time constant. I'm going to explain it. So this equation is saying the voltage then being discharged. And this is really important to know, because the IB does not write what those equations mean. This is only suitable for being discharged. Okay, so let's find tau. Okay, and when we find tau, we can write our capacitance. What was it?
It was 4.7 microfarads.
Okay, 4.7 microfarads. Okay. This is minus 6 times. And what was the
3.3 kilo ohm.
Okay.
Yeah.
Time constant is just resistance times capacitance.
Exactly.
And let's put those numbers. This is going to be 2. Sorry. Wait a second, please. All right. 6 times Euler's number over 6.3 times 10 to the power minus 3, because it is in milliseconds, over tau. And in this part, we find that it is around 3.992. It was like this, I think. and this is approximately 4 volts. And this is the voltage left on the capacitor, and it is saying falls by about 2 volts. So we are going to just subtract it. That's it.
Yep, that's all.
Let me put this approximation.
By the way, this is very delightful when you see on the calculator that 3.999 something. You understand that there is something correct I'm doing. Okay, should I proceed?
Yes.
Okay.
Yes, please.
Okay, so it says calculate the charge that flows through the circuit during the pulse. So since we have a pulse, we have the charge at position 1 and charge at position 2. So we should have Q initial and Q final, and therefore change in Q, meaning change in charge, should give us this answer, like charge flow during pulse. Let's say during the pulse we have to find delta Q. So our Q initial will be, we know that Q is equal to CV, meaning that capacitance times voltage, which we have it in the data booklet already, 6.0 times 4.7 times 10 to minus 6 farad, and this will be equal to 28.2 microcoulomb, and Q final will be equal to, we said Ege found it 4 volts, right Ege?
Yes.
4 times 4.7 times 10 to minus 6 farad, and this will be equal to 18.8 microcoulombs. Hence we can directly say that the change will be Q initial minus, anyone, Q initial minus Q final. It will be in the absolute value anyhow, since it will be changed, 9.4 microcoulomb. This is the charge that flows through it. And let's do not forget this number. Okay, should I go for it again? Because your annotation will not be
they are connected.
Yeah, they are connected.
Yeah.
So it says, now this battery has a charge capacity of 0.55 ampere hours, and the circuit produces 1 pulse each second. Calculate the time in years for which the battery can operate the circuit. So we will say that battery capacity will be equal to, since we know that it generates 0.55 ampere hour, we will multiply it by 60 times 60, since we know that it produces 1 pulse each second, right? So we will find, since we have H meaning hours, we will say how many pulses in 1 hour. So times 3600, and this comes from 60 seconds make 60 minutes, then 60 minutes make 1 hour. Coming from here, then we will find 1980 coulombs. This is the number of charges available in the in the battery. Therefore we will then say 1980 coulombs over, now let's see, we previously found over here that we will have 9.4 microcoulombs per pulse. Therefore, can we not say 9.4 times 10 to minus 6 coulomb times, it says in years, find them in years. Let's make it into years. 3600 times 24 times 365. I think you may understand why I did this. It says 1 pulse each second, so this is the number of seconds in 1 year, and this is the amount of charge per pulse, and this is the amount of charge available in the battery as a capacity, and this will be equal to 6.7 years. Right again?
Yes. I think it's a perfect solution.
Thank you very much. So next question.
Okay.
Okay.
Right. Let me annotate.
Sorry, 1 second, please. Yep. Now I got it.
All right. So let's clear this. So it's saying two batteries in series, each of EMF 6 volts, and having a negligible resistance replace the single battery. All other components remain same and compare the energy transferred. Okay. We don't have to read all of it. So it is asking each of EMF 6 volts. So if we have 6 volts here, connected in series, 6 volts here, 6 volts. In total, we have 12 volts, and it is the 2 times of the of the previous. So let's remind ourselves the energy equation for capacitors. It's in the data book. You don't have to memorize. This is the capacitor. This is the voltage, and we know that the voltage is being doubled. If it is being doubled, if it is being increased by a factor of 2, the total energy will increase by a factor of 4. So V doubles and energy is increased by times 4. We can write this. It's the perfect answer.
Great. Great again. Thank you very much. So I have a question for our 11th grade students. May I just skip to that again? Just something small that I would like to show.
Yeah. Yes, please.
So, would you be in favor of having those notes, 11th graders? Since you said wave phenomena, and I have received some answers on Instagram like wave phenomena is a little bit difficult for them. So, would you be in favor of those notes? I can just go through them. I can just share them with you. Just have a look at them quickly. I can share all of them with you. And also Kriz döner, sap döner, gün gelir hesap döner is also here. And I have more to go. If you want, I can share those notes with you. Those are my revision notes. So if you want to have them, I can just share them with you definitely. So again, where we were, where was our questions? Yeah, here. So you solved this question, we also solved it. Okay, they said fine. Okay, I will just share it with you.
We are in question 4.
Okay, I'll just come to that.
It's the question about waves.
Okay, this one, right?
Yes.
Okay, now we have waves.
It's a very good question, and 11th graders, please listen to it.
Yeah, listen to it carefully. By the way, there is many things to learn from this question. I'm just in love with this specimen paper, I guess. So, it says, oops, sorry. There is a microphone along a straight line and between the loudspeaker and the barrier. So there will be maxima and minima in this wave phenomena. So it says explain how a maxima and minima are formed in this case. So first thing, traveling waves. Waves will reflect in opposite direction so meaning that our original wave comes here, then they will reflect and it will have an opposite direction over here due to the reflecting barrier. So due to this opposite direction, we know that original and reflected wave will superposition. Due to this superposition, their frequencies are same, their speed are same, everything is same, just their direction are opposite. If their direction are opposite, what does it mean? This means that standing waves will occur because due to interference of those two waves, nodes and antinodes will form. Nodes and antinodes. So we can say that maximas are how can I say, antinodes, and minimas are nodes. So this is a minima, and this is a maxima. Anything I'm missing, I'm looking at it. So a maxima means constructive interference, and a minima means destructive interference. So we said there's a traveling wave, it reflects, having an opposite direction. Since they have all other quantities same except for the direction, they will superpose with each other, meaning that a standing wave will be created. And due to this interference, nodes and antinodes will form, meaning minima and maxima. Minima forms because of destructive superposition interference, and maxima forms because of constructive interference. Okay, should I go on? And by the way, again, this seems like an easy question, but 4 points.
Yeah.
Very much.
It's not easy. I mean, it's very important to write those terms.
You cannot assume something in IB. You cannot assume that, oh, okay, they know that minima is formed when destructive interference occurs. No, you have to write destructive or constructive interference, like that. You cannot assume.
You have to write those terms. I mean, you cannot write their amplitudes add up, their amplitudes are subtract. You cannot write it. It doesn't work.
Yeah. So should we go with the next question or pause for a second?
Oh yeah.
Okay.
We don't have much meeting time left.
Okay. We will pause for again 1 minute. Really sorry for this, but once again back in business. Actually, always in business. Sorry once again. So again, can you solve this one?
Yes, of course. Let's do it. Actually, this question is easy, but it might take some time to understand at first. Okay, let's. I drew it incorrectly. Let's read the question. The microphone is moved through 1 meter from one point of minimum intensity to another point of minimum intensity, and it says that it passes through 7 points of maximum intensity as it moves, and the speed of sound is given. Okay, we will use this for later. Okay, let's assume, let's write this. Okay, so maximum intensity is the peak part, right? So it will go like this. It says it is 7 points of maximum intensity. So this is our one wave. This is second maximum intensity. Okay, it goes for another 3, 4, 5, 6, and 7. But we need to add one more. Ah, sorry. Oh my god. Wait a second. Okay. And let me erase this. Okay. Okay, so saying it is moved through 1 meter from one point of minimum intensity to another point. So we know that minimum intensity, how many wavelengths is it going through? 1. This is 1. This is 2. And this is 3. And we have another half wavelength here. And we have 3.5 wavelengths. And the microphone is moved through 1 meter from one point of minimum intensity to another point. So it's actually giving us the whole 1 meter. I mean, this whole part is 1 meter. And actually, this second part makes it clear. And we need to divide 1 over 3.5 in order to find the wavelength. Where we find, I think it was
0.29.
29 meters, yeah. Alright.
And by the way, in addition to what Ege said, for example, you may find this one. Let me see if you will be able to see that. We have a diagram like this in our revision books. And you can see here that the number of maximum points that you are going through over 2 will give you the number of wavelengths that you are covering. So this may also help you. And yeah, next question. It says outline how you could use this arrangement to determine the speed of sound in air. So again, an experimental question. So IB says that do not be engaged too much with the formulas. Think exclusively as well. So it says, we will say measure length of each wavelength by using this methods that again showed us. Wavelength between maxima or minima positions via or by using a ruler. Indicating the equipment is always helpful to show examiner that you are more engaged. And then take the mean wavelength. Next, you will say use an oscillator. So again, for example, we have alternatives to oscilloscope, by the way, not oscillator, by the oscilloscope, to find frequency of waves.
Or you can simply write frequency meter.
A frequency meter, you may say even an electronic guitar tuner, anything you can say. Then you will say use formula. Which formula? C, meaning velocity of sound, is equal to F frequency times lambda wavelength. Hence you will find C.
This is actually an unusual question because I have never seen such question in IB past papers. I mean, like this question, outline how you could use this arrangement. It's like a paper 6 question from IGCSE.
Definitely. Right. Next one. Okay, do you want to solve it again?
Yes, let's go for it. Alright. Let me read the question. A power station burns natural gas at a rate of 35 kilogram per second. And the power output of the station is 750 megawatts, and the efficiency station is 36%. Calculate the energy provided by the natural gas each second. Okay, IB does its little tricks again. So it has given us the power output of the station at first, but it is the power output after we take the efficiency. I mean, energy provided needs to be more. Okay, let's calculate it. It's pretty easy. 7.5 over 10 to the power of 8, and this gives us megawatts, times 100 over 38. And when we do this, we will find that 1.97 times 10 to the power 9 joule per second. Or you can simply write watt. Yeah, that's all.
Yep. Calculate the specific energy of the natural gas. I think you can go on with this because this is already...
Yes, they're related.
Yeah, they're already related. Just remember 1.97 times 10 to 9 from the previous question.
Okay, let's write it before I forget it.
Okay.
Joule. So it is asking specific energy. We know that we find joule per second. And we know that it is being consumed at 35 kilogram per second. Okay, why don't we take in 1 second? And we will just eliminate this, okay? And to calculate the specific energy, it is energy over mass. Let's write it. Over 35 kilograms. And where we find, and it is saying appropriate units. Before we write this, it is asking appropriate units. And when we do this, you will find that it is 56 megajoules, and also we have kilogram per kilogram. This is really important. When IB says state the appropriate units, it is for 1 mark, and you need to specify it. It's for 1 mark, and it is a very easy, 1 mark.
Again, you can see this is 3 points. I mean, if it had 2 more points, it would be a Kirchhoff question. But this is such simple question.
Exactly. So be careful, guys, please.
Yeah.
Okay, let's pass to the second question. Burak, if you want, I can also solve it.
Yeah, sure. Let me clear it for you.
Okay, so it is asking outline why much of the world's energy is provided from fossil fuels. So let's think, and there were also some news that the fossil fuels, we will have enough fossil fuels by 2018, 2050. So 50. So we can say that there are abundant fossil fuels presently, and we can say that, I mean, we have pre-existing infrastructure.
Yeah.
And
everything is arranged according to fossil fuels, like the factories.
For example, if you want to build a nuclear power station, actually it is going to cost you too much, building it, and also the solar panels as well.
Yeah.
It's going to cost you too much, and it needs more direct initial investment. So pre-existing infrastructure will be the key here.
Yep.
Okay, these are the 2 important points.
Exactly. Thank you again.
You're welcome.
By the way, I shared a link with you, our Felsefesine website. You can just take our Felsefesine card for free, and you can reach many class materials, many philosophy, popular science, and mathematics materials that will be further shared with you. So, next question. There is a suggestion that the temperature of Earth may increase if the use of fossil fuels are not restricted. So it says, using greenhouse effect concepts, explain why this temperature increase may occur. Now, the reasons can be written in the form of bullet points here, and we will say the first thing is that there will be increased proportion or amount of greenhouse gases from fossil fuels oops, what is this? Fuels in the atmosphere. And therefore there will be more absorption of infrared light, let's say, by atmosphere. I just wrote it in the shorter form, and so an extra energy will be reflected back to Earth. Let me just summarize how this occurs. So there are some greenhouse gases, including carbon dioxide, in which, due to their polarity, they are having a different vibration as the sunlight hits to them. Due to this photonic effect, we know that their vibration frequency will be at a certain level. Therefore, they will absorb infrared light, and infrared is, as you may know, hot. So it is used as a therapy as well. So since it will be hot, the sunlight comes to the Earth, reflects from the Earth due to its albedo, then it will be absorbed in the atmosphere, but it will be also reflected back to the Earth. So it will be trapped inside the atmosphere, increasing the temperature of the Earth. I didn't miss anything, right, again?
No.
Okay, thank
and
you.
guys, this is actually a very important concept to learn, because I have seen at least 3 questions regarding this enhanced greenhouse effect. Always the same bullet points. Always. I mean, this is very important to learn.
By the way, may I give a reminder about the next question again?
Yes, please.
You can see outline how scientists do this. This is a very common concept in the IBDP. For example, I was solving the past paper question. This is to increase your vision about science, I think, because they said, for example, why peer review in scientific journals is important. What does it ensure? So this time, again, will show us another concept related to scientists and the global problems.
Okay, so it's saying outline how scientists continue to attempt to resolve the climate change debate. So there are some scientists who say that climate change does not exist by human activities, and the others say that climate change occurs because of human activities. So to resolve this issue, and you need to be aware of this debate actually, the IB asks this, I think, in at least 3 past papers, at least. So firstly, we can write, and this is a very common point, it could be improved modeling. Modeling of climate data, or greater data collection. This is quite possible to create new hypotheses. And the other one is international collaboration, where scientists can create panels or meetings to discuss these issues. And greater international collaboration. And if you take a look at other past paper questions for IB physics, you can see the similar bullet points. So just be familiar with these issues, with these climate change debate, and you will be perfectly fit to gain the extra 1 mark from here.
So again, actually, I have a question right now. So
let's show it.
We could also say green science as well, right? Green science could also come here, I guess.
Green science?
Yeah, like use of green chemistry
right.
Yeah, I think this could also come under the collaboration. So, question 5. So, identify the value of x. We have conservation of charge, conservation of momentum, conservation of everything. Physics is conserved. So, we will just say, it says find the value of x. So, let's have a look at it. 235 plus 1. This is 236. And over here, we will have 148 plus 85, making 233. Yeah, right, 33. And we have 1 over here. 233 plus x times 1. So what would make it correct? X is equal to 3. Okay, the following data are available, it says. Determine in mega electron volts the energy released when 1 uranium nucleus undergoes nuclear fission in reaction D. What will we do? Products over reactants. Right? We will say
yes, exactly.
LA for this one, 147.932 plus For bromine we have 84.9110 and plus 3 neutrons, right? Okay, I will just say 2 neutrons because there is already one on the other side. 2 times 1.009 minus this part. I already subtracted this one from here, so this is why I wrote 2. For uranium we have minus 235.044, and it was equal to, I guess,
Burak, it is 0.184.
okay,
U.
For U. Those are all in U, by the way.
Atomic mass unit.
Atomic mass unit. And we have the conversion. 1 U is equal to 931.5, right?
Yes, exactly. And this is in the data booklet, guys.
Yeah,
you don't have to memorize it. And I will tell you the location of this data.
It was in the very first
page, fundamental constant, page 2 of the data booklet.
So it is in mega electron volts, by the way, right? Again,
yes, mega electron volt. Exactly, yes.
Times 931.5 will be equal to, let me tell you,
171 mega electron volts.
Great, we found it.
And it is an easy question again, guys.
Just like chemistry. Just like chemistry.
3 points. Just do not lose those marks. Even 1 point matters for a 7.
Definitely.
Or a 6. Okay.
You may remember from IGCS, I guess, right?
Yes. Okay.
By the way, thank you very much, Ezgi, because Ezgi subscribed to our website. Just a few seconds
ago. Ezgi.
Welcome, Ezgi. Welcome to the group. We have 4 people right now. Ege, Zeno, me, and now Ezgi.
Welcome, Ezgi. Burak, I cannot clear.
Okay,
now it's cleared. Okay. So, it's asking outline with reference to the speed of neutrons, the role of moderator in a nuclear reactor. Okay, so let's do a very quick revision. Moderator, and this is the one I usually confuse it with, control rods. And this is the 2 parts of the nuclear power station, which IB usually asks. Could you move down a little bit? Yeah, yes. Okay, so I can write here. Okay, so for moderator, we know that it slows down neutrons. And for control rods, and this is actually pretty easy to remember, I will tell you the trick. It controls speed of reaction. Bro, I think it was chain reaction.
Chain reaction.
Yeah. Speed of chain reaction. Or regulate. You can write regulate. Doesn't matter.
Because just it absorbs them.
Yes. And you can actually remember this from control. Control. What is it? You control speed. That's it. Easy to remember. Piece of cake. So let's answer our question. Let me erase these. Okay, so we know that. Let's state the facts first. Do not write the answer. Do not jump right to the answer. We know that neutrons are emitted at high speeds. In fission reactions, I mean. Fission. But we know that, high-speed neutrons do not cause fission, and they do not sustain the chain reaction. It just happens, and it doesn't continue for the other nuclei. Let's write it. High-speed neutrons. Sorry for my bad head, right? do not cause fission. And for the next part, we know that neutrons collide with atoms from moderator. And where they collide, they will lose some of their energy. If we think of in terms of energy conservation, they will lose some of their energy and their speed will be reduced. And they can sustain the chain reaction. That's it. And this is actually not a challenging question, but it requires some knowledge. And if you know these points, like high-speed neutrons do not cause fission, this is a very important point, then you will be gaining those 3 marks.
By the way, again, may I do something doping hafıza thing?
Yeah, let's do it.
Okay. It's about fission and fusion. Some people may confuse it. May I say how I remember this from 9th grade?
Fuse, right? The word fuse.
Actually, I'm doing this one. Fusion occurs, let me write it like this. Fusion occurs in sun. That's why I said sun. This is how I remembered it from 9th grade.
Oh.
Yeah. And fission does not have it, so I remember it from the middle letter U. Something interesting, but
and actually these things are very easy to remember.
Yes.
And I remember it from the word fuse. The word fuse means that to get 2 things together. And you can also remember it, I mean, from the root of the word.
Yeah, and when you make it into a humorous form, it becomes more effective. Because you say, oh my gosh, am I going to memorize it in that way? But since it sounds funny to you, you remember it in that way. It's always the case. Now good.
Alright, this question is perfect.
Okay, Cavendish experiment. Cavendish experiment is a famous experiment for gravitation and so on. So now we are asked Newton's law of gravitation. So we will say, let me write first this one. F gravitation, let's with this one, F gravity. F gravity is equal to Gmm over r square. So we will make some directions from this. We will say gravitational force is proportional to product of masses of 2 masses, and secondly we will say that it is inversely proportional to the square of separation between masses. So we will directly say actually Fg is proportional with mm, and Fg is indirectly proportional with 1 over r square. But please do not forget that again we have been making a lot of mistakes related to this as well during the exams. And the separation means from center of masses, the distance between the center of mass between the 2 masses, not from their surfaces. This is important.
This is very important.
And we have a question related to that here.
Yeah.
So next question. Here, yes, this was the question, by the way. Will we go for it again?
Yeah, let's go for it.
Let me just clear it for you. By the way, thank you very much for the revision of moderator and controllers.
Okay, so estimate the gravitational force between the spheres when the spheres were in contact. Okay, so it already gave us these. Okay, you know that these are the center of masses as Burak mentioned, and it is very, very important to remember. And this may actually be the reason why you make mistakes in paper 1 questions, because they always trick.
If this was the case, there would be no gravity on the Earth, since we are touching its surface already.
Yes. Okay, so we will remember this equation, guys. I cannot write G. This is G, letter G, not 6. So the gravitational constant is this, and you can actually find it in the data. You don't need to memorize it. And we know that this mass is 47. Other mass is 0.73. All right. And let's write radius, which is quite important to know. Like when we do this, we will find that this is 125 millimeters, but we always need to write in SI units.
SI units.
Meter, kilogram, ampere, volt, coulomb charge. Always, always like this, guys. And we don't use
have
candela.
Like yeah.
Okay, let's CD. And that's it, guys. If we write this in terms of meter, we will find that it is 1.25 times 10 to the power minus 1 and square. Do not forget square, please. And at the end, we find 0.15 micronewton.
Yep.
Yeah. Or 0.15 and or minus 6 newtons.
Yep.
I mean, you don't have to write like this. You can also write.
Yeah, or 1.5 times 10 to minus 7 newtons. It's completely up to you. Completely up to you.
Yes, doesn't matter.
Aha, again.
Oh, this question is perfect. The next question is just perfect.
Next question is like it was about to become a paper 1 question, but somehow it became a paper 2 question.
Yes.
It is such a question.
Very, very hard question, actually. I mean, you have to be very careful with this.
So now, this student repeats Cavendish's experiment using lead spheres with twice the radius. Discuss the effect on your calculation in BI of doubling the radius of both spheres. Again, while I was solving this question in the morning, I thought I was supposed to only think about the radius.
Yeah, it has density, man. Please.
Density. Please remember that. Density is equal to mass over volume. And this is a sphere, so volume of a sphere is equal to 4 over 3 pi r cube. Okay, so first thing that we realize is, if we are doubling the radius of a sphere, what will happen? Its volume will be 8 times bigger, right? This means v to 8v, since r cube 2 to the power 3. If this is 8v, density must remain constant, so it will be 8m. Mass is 8 times. Now, there is another point again. It was proportional to mass product.
Yeah.
It was
64.
m. Therefore, 8 times 8, since it's mass product, 84 times. Let's keep this in mind, okay? This is the first thing to keep in mind. Fg will be 84 x we know. It will be multiplied by it. Actually, we can write it like this as well. Fg, let's say. Okay? Secondly, we have separation. If the separation of two spheres is doubled due to the doubling of the radius, this means that we know Fg is proportional to 1 over r squared. So what will happen? It will be Fg over 4. Right? Separation is doubled. So this means that Fg, gravitational force, is quartered. Then I will just use those two, 1 and 2. 64 Fg times Fg over 4. What will they give me? 16. Sorry, 16. Fg will increase by a factor of 16. This is the answer. Nice question, right? Again. Great question.
Oh my.
Do not forget
God.
about the mass. Do not forget about, first of all, density. Hence, find the volume and apply it into mass form. After you find the increase in mass, don't forget gravitational force is directly proportional with mass product. Multiply them. Then use separation, 3 points, and you will receive 4 marks for this question. Great.
And guys, it would be a perfect paper 1 question.
Perfect paper 1 question.
Perfect. I mean, just don't fall for this trick.
And you can see that actually a paper 1 question has an extensive points of 4 marks. Normally this would be a 1 mark question in the paper 1 section, but now this is worth 4 marks. Very important. Next question. I can solve it as well. In Cavendish's original experiment, the large sphere was part of an isochronous pendulum. State what is meant by isochronous. So this means the period remains constant for any amplitude of swing.
Burak, may I ask you a question?
Yeah, sure.
I think we did not learn this with our physics teachers.
Yeah, I remember talking about this during the break. Maybe this has been removed in the 2016 specimen. It is possible.
Probably, yeah.
Probably. You may just check the definition booklet if you have one online to see if it is gone or not. Okay, question 7.
Alright, another perfect question.
Another perfect question. I love it. Let me just show the question again. This is electromagnetic induction. I guess 11th graders haven't approached to this point yet. This is HL part.
Yes.
So
electromagnetic induction.
We have a magnet, we have a solenoid, and the coil has 240 turns. Do not forget about them. 240 turns, and cross-sectional area is this much. And this is the flux density B graph with time. Due to the spring movements, simple harmonic motion of it. Again, do you want me to solve this one because I have to scroll up and down to show some points?
Yeah, no problem.
Okay. So it says determine the maximum electromotive force induced in the coil. So in here, we will say, okay, phi magnetic flux, right, is equal to BA cosine theta in the data booklet already, and we know electromotive force is equal to N times delta phi over delta T. This is also a point. Now I will firstly find, so this means that, by the way guys, okay, let's make a quick revision. Okay, high electromotive force for high epsilon, we should have high change in, maybe I should use the red one, high change in phi, or small change in time, right? So for high change in, how can I say, phi, also high number of coils, okay, number of coils have to increase. So again, if I would like to change my phi, right, high change in magnetic area, magnetic force, right, or I should have higher change in cross-sectional area, or I should have better orientation. I just used the formula. Electromotive force is equal to N times delta phi over delta T. So I should either have more number of coils to increase my epsilon, or should I decrease my delta T to make this delta phi, or I should increase my delta phi electromagnetic flux change. For this flux change, changing this flux change, I should either have higher change in how can I say, B, meaning the magnetic flux density, or have a better orientation for this theta over here, or I should increase my cross-sectional area, change in my cross-sectional area. In this one, B will change. We will go with this one for this experiment. Therefore, if we are looking for rate of change of magnetic flux density, right? Where is the highest change? It is at the point where the gradient is the highest, right again? So,
Yes.
in this graph, we will check to find the highest EMF, the highest gradient on this graph. There are 3 points. Let me just identify them here, here, and here, because you can see that they are the steepest parts. Now, I will just do something like this. I hope it will be correct because I am doing it by eye right now. Since we are in the live video, you can do it more carefully. I will draw a line tangent to this point, okay? Tangent to this point. Or I should draw it like this so that I can go through it. It looks nice, right? I will calculate the gradient over here. Let's calculate the gradient. So one thing that you can do is that, let me go for 0.4. Okay, let's say it's here, and maybe 0.6. It's also over here. So this will correspond to almost 1.00, and this point will correspond to almost okay, sorry for this problem once again. Now let me go back to here. Okay, I was calculating the slope, right? Yeah, I was doing that. So I will just take that point, and I think, again, can we say 1.10 for this point for now? In fact,
yes.
It is not. Okay, I will just take 1.10. So let's find this one. Change in here, change in B is equal to what? 0.10, and change in time over here is 0.2. Okay, so let's go to here. Okay, so my phi at this point, it changed from, my phi has changed 0.10 times my cross-sectional area was 2.5 times 10 to minus 4 times 10 to minus 4, and cosine 90, so it is already, sorry, cosine 0, it's already 1, no problem with this. And finding this 2.5 times 10 to minus 4, it will be equal to 2.5 times 10 to minus 5, right? And then I will say, let's write it over here, n was 200, what was it, 40 terms, times 2.5 times 10 to minus 5 over 0.2, so it will be equal to something like 0.30, I guess, right?
Exactly.
0.30 times 10 to minus 3 volts, meaning 0.3 millivolts. Okay. Yeah. So this is how we do it. Next question. I will let you annotate.
Burak, would you mind if you do this one, because
Sure.
like it is very hard to write on it.
Okay. So it says the spring is changed and the frequency has been doubled without changing the amplitude of oscillation. Okay, fine. And it says use this axis to show the induced EMF in the coil, but know that the equilibrium position, the coil is at the equilibrium position when t is equal to 0. So you can also cheat from the first question. It was also at t0, and we said this is a pink dot, meaning that the change in magnetic flux density is the highest, meaning that we have the highest EMF, right again?
Yes.
Okay.
And it should be the double.
Yes. So can we not say that? Can we not say that EMF will be at the top point, maximum point at the beginning? So isn't this a cosine graph? Cosine or minus cosine graph?
Exactly.
It is. So let's also identify our period. If the frequency is doubled, period will be halved, right? What was the period here? 1 second. Our frequency is doubled. So this means that period should decrease. We will do exactly the same thing. This time it will not be 1 second period. It will be 0.5. Hence, if the frequency is doubled, it is directly proportional with the EMF, meaning that this time it will not be 0.30 millivolts. It will be 0.6 millivolts. Let me write it like this. 0.45, let's say 0.30, 0.15, 0.0, or just like 0, minus 0.15, minus 0.30, minus 0.45, and minus 0.60. Is this correct? Let's draw a cosine graph accordingly. It will approach something here. Just something like this. Okay, I mean, I think you can understand it, right, again? I mean, cosine graph.
Yes, I mean, it's saying sketch, guys. You
yes.
don't have to put every point correct.
So you can understand that our maximum EMF is now doubled. Our period is halved to 0.5 meters, and since we are starting at the point of equilibrium point, our coil, it means that now EMF is at the top point. You can cheat from here to the pink dots. You can see that the highest change in magnetic flux density, meaning highest EMF, as you can see in the equation here. So this is the graph, almost the graph.
Burak, may I add something else?
Yeah, sure.
I think it's, could you let me annotate, because I want to add a little something, maybe a little trick.
Sure.
Okay. Guys, when you are writing, let me write it in white to write on the black screen. When we are finding the EMF maximum in alternating current, we find it by using, this is the omega times n, this is the number of turns, times B, magnetic field, and this is also the area. You can actually memorize it by, learn it by woman NBA, like the NBA, National Basketball Association. And the formula for this is woman NBA sine omega times t. And when frequencies increase, like 2 pi times f, frequency is equal to omega. So when frequency is doubled, also the EMF maximum will be doubled.
Yeah.
And actually, this is going to give you an advantage, because most students would think that it is cosine, but in some paper 1 questions, it is very important to consider this.
Yeah, right. By the way, I realized something, guys. May I just fix it?
Which one?
In my part. It is in my part. Here. I made a mistake. Just a second. I'll just show it to you directly. Which one is the last changed one? Okay, here. Guys, I made a mistake here, so you can still see my screen, right?
Yes, we can. Okay. I guess I will check the live video. It's a bit delayed.
Okay, I think you can see it. Yeah. Guys, this is the solution. I will say why I made a mistake. Just see
gradients, right?
Yeah, because I forgot about one thing, and you should not forget about this. Let me tell you what that is. Okay, are you ready?
Yes, I
This
think we
is,
are ready.
check the graph. This is 10 to minus 2 Tesla. Okay?
Oh my god, yes.
So, while making the calculation, you should make sure that it is 0.10 times 10 to minus 2 times 2.5 times 10 to minus 4. Okay? Times 10 to minus 2. So I guess this will be minus 7, right? If I'm not mistaken. Yes, I guess. Or this is 6, sorry. Minus 6. So you should write it here, and this should give you the answer, okay? Sorry for that. Okay, next question. You or me? If you want, I can go.
I can,
Okay,
no problem. Guys, this part,
just read it.
Burak,
I will
could you let me
scroll up.
annotate?
I think you can read it because we will draw a diagram.
Yeah. Okay. Label the diagram of the magnet and the coil on page 18 with arrows to show the direction of the conventional current. Okay, so in this part we have to remind ourselves of the Lenz's law.
Yeah. Let's go up.
Okay, so what does Lenz's law say? Burak, would you let me annotate?
Sorry.
Okay, so Lenz's law says that, for example, if you are approaching this, oh my god, I forgot it in the white. Okay, if you are approaching this magnet here, this coil will not want any increase in its magnetic flux. So this top of the coil will act as North Pole, and this is going to act as South Pole. And it's going to repel it. It will say, I don't want you. If it was South, then this part would act as South. Let's erase it, it's not. And our conventional current will be, if we use our right-hand rule, let's use it. We will see that, I mean, I cannot show my hand to you, but let's imagine your right hand and put your thumb at the point where it is pointing the upward. And your 4 fingers will show the direction of the current, which will be like this.
While you are explaining it, I will just show it like this, guys. Since my image is mirrored, you can see it. It will be in the direction of. Okay.
And he actually answered the second part.
Yeah.
Question.
So, shall we proceed?
Why not, guys? Do you have any questions?
Yeah, if you have any questions, please.
Yeah. I think we don't have many 12th grade viewers.
Yeah, I think so. I guess we have 11th graders here. Which is pretty nice to hear, actually.
Yeah. And they are eager to learn.
I skipped this question because we already answered it.
Yeah.
Okay, now. Good question. Actually, our teacher also likes these kind of questions. Gravity, etc.
Gravity. IB also likes them too.
Yeah. So, gravitational field strength. It means force acting on unit mass. So what is 2 points here? Unit mass, force acting. This is it. Next question. Can I solve it again? This one?
Yeah, why not?
Okay. So it says determine the ratio distance of x from center of Earth, distance of x from center of Moon. X is the point where F gravitational is equal to 0. Okay, there is no. So actually Vg is 0, sorry. Vg, gravitational field strength is equal to 0. And we know that, let's write it like Earth and Moon, okay? Earth and Moon. Meaning that Gm Earth over I will say x square will be equal to gm over y square at this point, right? This is the formula that we have. Therefore, we will say x over y is equal to me over m moon, mass of moon, meaning when you make this calculation by using data from here, you will find root 81, meaning the ratio is 9. So you will just say like, since we know that from the Earth, this is the, how can I say, gravitational field strength, and this is from the gravitational field strength due to moon, they will be equal at point x, because it is stated in the question at x resultant gravitational field strength is 0. That's why they have to be equal. I said x square is the distance from center of Earth. I said this is x, and I said this is y. Good, right again? No problem with this one.
I think no problem. Do you have any questions?
I guess no.
I guess not. Yeah. Okay.
Calculate using the data total gravitational potential at the surface of the moon due to the Earth and moon.
Very easy, guys. Very easy. If you want, can I solve? I can solve it.
Here you go.
All right. So in order to find the total gravitational potential, we need to just add them up, and because they are both negative, we will just add them up. No problem with that. Let's say for the moon, it is B times is equal to minus G. This is gravitational constant. Mass of moon over R. And when we do this calculation,
let me tell you, you will have minus 2.9 megajoule per kilogram. By the way, do not forget the units, please.
Yes, it's very important. And Earth will have B is equal to minus J times mass of Earth and separation. Separation from the center of mass of Earth to surface of the moon, and it also gives the data in the upper part of the question, the beginning of the question, so no problem with that. And it is minus 1.1. Yeah.
Yep.
Megajoule per kilogram. And we will add them up, guys. No problem.
4.0 per kilogram. That's it.
Is guys, three free points.
Now another good question in the next question, okay? It says G is at a point on the surface of the Earth and L is a point on the surface of the Moon. Using the axis, sketch a graph to show how the total gravitational potential varies with the distance from G to L. So left here is, this is Earth, this is a point from Earth, this is a point from Moon. So logically, Earth is much greater, has a much greater mass than Moon. So we imagine something like this. This is Moon and this is Earth. So the point X from the previous questions, point X over here, should be logically closer to Moon because this already applies much more force on that point X. So it should be somewhere here, right? So I say, always staying below 0, gravitational potential, this is 0. Let's say this will be the point where it will be equal to 0. Then I will say the gravitational field strength between those points is 0. Gravitational potential is not 0. This will be a graph like this. Why? Because as we get closer to Earth, it has a greater mass. So it has an exponentially increasing gravitational potential. And again, we said this point, actually indicating X, must be closer to, like 1/10 closer to Moon, considering the distance between the Earth and Moon, logically, as it is smaller, it should be here, so a smaller distance will give it a higher advantage, and then a smaller exponential increase towards Moon. I hope it's understood, right?
Burak, may I add something else?
Yes,
a little
sure.
thing maybe.
Sure.
I think it would help our viewers to understand. No equations needed, I think, but the point where we found X, and this is where there is no gravitational force from either Earth or Moon. The net gravitational force is 0, so it's going to be easier to remove it to infinity.
Yeah.
It's going to require less energy to remove it because the net force is 0. So the point X will be closer to the Moon, and also its gravitation potential will be less negative because it requires less energy to make its energy 0. Which means it goes to infinity.
Exactly. Okay. So the next question. Last question. This is the last question, guys.
Oh my God.
We're ending up. Again, this is HL.
This is topic 12.
Yes, and this is the last topic that we have covered. So it says an electron and a positron can be created through pair production when a photon interacts with a nucleus. So this question is a question on its own. I have to mention it. This question is a question on its own. Why? Okay, let me show you. Explain why there is a photon frequency below which an electron-positron pair cannot be created. Einstein said, change in energy is equal to change in mass times c squared, right? Now, again, I am asking you, does a photon have a mass?
Of course not.
It doesn't have a mass.
It needs to have energy to convert it into mass.
What will be the change in mass? We are creating one electron and positron pair. Both have the same mass of an electron, right? So wouldn't it be 2 mass of an electron? From 0 to 2 mass electrons, right? 2 ME. Now, can we not say a photon energy of a photon is equal to h times f, right? So this means that by using those two equations, delta E will be equal to 2me times c squared, right? And the photon energy will provide this energy, okay? Photon energy is the energy that will provide this much amount of energy. So we can see that h here is a constant. H is a constant. So what is the only dependent here? Frequency. Therefore, frequency should be at a certain point. At a certain point to provide that energy, because Planck constant is a constant. Second question. Again, may I carry on with this part as well?
Yeah, I think it would be better.
Okay. So, change in energy from the first equation, I said from here, you can see that, I said 2me c squared, right? And I said photon energy photon, or I could even write like this to show you some more notations, right? Is equal to hf. Let's equate them because it will come from this. 2me c squared is equal to hf. Now what I am going to do is that I will use the data booklet, okay? I will use the data booklet and I will solve for f. Therefore f will be equal to, let's solve it first, 2me c squared over h, right? F will be equal to 2 times, by using the data booklet you can find that the mass of an electron is 9.11 times 10 to minus 31 kilogram times c square, meaning 3 times 10 to 8 meters per second square, over Planck constant. Planck constant is 6.63 times 10 to minus 34 joules seconds. Hence, our frequency will be equal to what? Let me just tell you directly. Okay, I found it. 2.5 times 10 to 20 hertz, and it was saying the calculate the minimum photon energy, so we found photon energy to be this, right? That's it. That's how you do it. Should I go with the last question, very last question also again?
Yeah.
Outline why a nucleus must be involved in the reaction. Because we have conservation of both momentum and energy. What does it mean? Why a nucleus? Because nucleus can absorb the momentum, allowing reaction to occur. Now again, may I please draw lastly the Feynman diagram of this reaction? A Feynman diagram. I will just show it.
Make it more clear.
Yes. I will just draw it over here. You can see both of them at the same time. So we will draw first of all our axis, just like this. I will use a ruler to become more sciencey. Okay, this is space and this is time. This is time. Now I will say there's a photon approaching, okay? There's a photon approaching over here. This is a photon. I can just write this one like a photon. When a photon comes, I will say a positron will be created by this direction. Positron, E positive. And an electron will be created just like this. Electron-positron pair. You can see it over here. Electron-positron pair. E minus and E plus pair. Then we will have the nucleus over here, but because it will have a direction like this, and then I will just say that there comes the nucleus. Okay? This is why we have the nucleus. Feynman diagram shows us that we have to equate both momentum and energy. We have to conserve both of them. That's why we have a Feynman diagram like this. Let me just title it as well. Feynman diagram for photon 2, E minus and E plus pair. So guys, this was the end.
And that's all, folks.
That's all, folks. Thanks very much for watching. Please subscribe to my channel. So guys, this was the end of Specimen paper 2, in which we, I guess, learned a lot of information. Even while we were solving it, we had some concepts that confused us, so we became familiar with them. We tried to explain it as much as possible. Thank you very much, Ezgi. Thank you very much for watching us, and thank you very much for everybody who is watching us during this live video. Even we have some people who are not taking physics, but they are watching this video, they are following up. Thank you very much to them as well. We have the mocks coming up, or even IB exams may come out. So should you have any questions, please ask them. You can contact us. You can check our Felsefesinde website. You can check it as well because we are working on that as well, and we will be sharing all of our class materials with you via this if you take your Felsefesinde card. And this was the end. Do you have anything to add again?
No, guys, please study hard and take care.
Yep, thank you very much for watching. See you in a next live video, which I guess we will be doing frequently about economics, mathematics, physics, chemistry, and so on. So thank you very much. Get tuned, stay tuned. Bye bye.